today's goal of this lecture. Today I will see prime ideal and maximal ideal just as a review. Till long day I have not defined ring theory. Actually, prime ideal and maximal ideal, this topic is very important for any competitive exam. So, today I will discuss prime ideal and maximal ideal just as a review. At first, let's see what is the definition of prime ideal. At first, pause my video and recall oneself what is the definition of prime ideal, because this is the review part. R be a ring and let I be an ideal where I is any proper ideal. Sorry, I contain R. Sorry. If any two arbitrary element AB belongs to R such that product of these two elements belongs to I, imply either A belongs to I or B belongs to I. This is the definition of prime ideal. Note for simplicity, with usual notation of prime numbers, this is the same as the actual definition of prime number. What is the definition? Recall. P belongs to natural number where P is a prime. If P divides AB, that implies P divides A or P divides B. That means P divides AB. This implies AB belongs to PZ and P divides A. That implies, this is the if and only if condition, A belongs to PZ and P divides B. That implies B belongs to PZ. So, here obviously this AB belongs to positive integer. That means prime number which I have read in school, prime number which divide only oneself and 1. So, this is the similar notation as prime ideal. So, prime ideal and prime number, this is actually the similar notation. So, prime ideal as generalization of prime number. Now, let me show some example of prime ideals. How look like the prime ideals of integer? This is my question. How look like the prime ideals of integer? At first, if fourth set is a prime ideal of integer, for this 4 equal to 2 times 2 which belongs to 4z. But notice 2 does not belongs to 4z. So 4 4z is not prime ideal of integer. Then how look like the prime ideal of integer? The prime ideal of integer are look like nz type, where these n are prime number. Now I will see, is 0 is a prime ideal of Z6? At first say, how look like the ideal in Z6? These are 0, 0, 3, 0, 2, 4. This is class 0. This is belongs to class 3 and this is belongs to class 2. These are ideal in Z6. Now my question, is 0 is prime ideal in Z6? Notice class 3 times class 2. Since class 3 and class 2 belongs to Z6, class 3 times class 2 equal to class 0, which is belongs to Z6. But class 3 does not belongs to class 0. Also class 2 does not belongs to class 0. That means the 0 ideal is not prime ideal in Z6. Actually, 0 ideal is prime ideal when the ideal is integral domain. 0 ideal is prime ideal when the ideal is integral domain. So 0 is prime ideal of integer because Z is a integral domain. Why this is prime? Notice, if AB belongs to arbitrary element of integer, then A times B belongs to integer. That imply A times B equal to 0, and since Z is integral domain, then A times B equal to 0, this imply either A equal to 0 or B equal to 0. And this is true because Z is integral domain. So 0 is prime ideal when the ideal is belongs to integral domain. Otherwise this is not possible. Next prime ideal, consider the polynomial ring Qx and consider this is the ring. Then ideal generated by x. Is x is ideal generated by x is prime ideal? Ideal generated by x means actually fx times x, where fx belongs to qx. This is means actually all polynomial in qx whose constant term must be 0. Let for this fx gx belongs to qx and fx times gx belongs to ideal generated by x. That means those polynomial whose constant term must be 0. That means the constant term of fx times gx is equal to 0. that imply obviously either fx belongs to ideal generated by x or gx belongs to ideal generated by x. That means in fx either constant term is equal to 0 or in gx either constant term is equal to 0. Then we can tell ideal generated by x is a prime ideal. Similar to before, not only ideal generated by x, ideal generated by x minus 1, x minus 2, x minus half, these are all prime ideal in Qx. But if we consider ideal generated by x square minus 1, this is not prime ideal in Qx. Why? Because notice ideal generated by x square minus 1, this is equal to, we can write this as ideal generated by x minus 1 times ideal generated by x plus 1. Ideal generated by x minus 1 times ideal generated by x square x plus 1, this is belongs to ideal generated by x minus 1, x square minus 1. But neither, this is look like AB times, but neither ideal generated by x minus 1 belongs to ideal generated by x square minus 1 nor ideal generated by x plus 1. This is not belongs to ideal generated by x square minus 1. Because here ideal generated by x plus 1 means set containing the element x plus 1 times fx, where fx belongs to qx. Similarly, ideal generated by x minus 1 means set containing the elements x minus 1 times gx, where gx belongs to qx. If we consider ideal generated by x square plus 1, this is be prime ideal in Qx. But this ideal, ICM ideal, is not prime in Cx. Why? Because in Cx, ideal generated by x square plus 1, this is equal to ideal generated by x plus 1 times ideal generated by x minus 1. This is AB times. This is belongs to Cx also. Ideal generated by x plus I, neither x plus I nor ideal generated by x minus I, this is not belongs to Cx. So this ideal is not prime in Cx, but this is prime in Qx. Because in Qx we cannot factor x square plus 1 in such type. Okay. First know that the maximal ideal R, B, S, C, R, U, a proper ideal M of R is said to be maximal if there exists one ideal M dash of R such that M contain M dash, then either M dash equal to whole M or M dash equal to whole ring R. That means if this is R and this is the subset M, then we cannot tell there exists any proper ideal of M dash. And this M dash either M or the whole ring R. M is one proper ideal which does not contain in any figured ideal. Okay? In field, there exist always two ideal, zero ideal and field itself. So, in this, only prime ideal is zero ideal. Similarly, maximal ideal is also zero ideal. Now, let's see how look like the prime ideal of Z10. Prime ideal of Z10. At first see how look like the ideal of Z10. Ideal of Z10 are actually divisor of Z10. This would be 1.10 Z10, which is equal to actually Z10. Divisor of 10 are 1, 2, 5 and 10. So 1.Z10 is actually Z10. 2.Z10 which contain 0, 4, 6, 8. 5.Z10 which contain the element 0 and 5, and 10.Z10 only contain the element singleton set 0. Notice here the prime ideal are 2 and 5. 0 is not prime ideal because 2.5 is equal to 10, which is congruent to 0 in mod 10. But neither 2 belongs to ideal 0 nor 5 belongs to ideal 0. So 0 is not be prime ideal, only 2 and 5 is the prime ideal. Actually, number of prime ideal in Z10 are actually the omega n, which is equal to number of prime divisor of n. Number of prime divisor of n, which is Z10 mean 2 into 5. So number of prime divisor is 2. This is not only prime ideal only Z10. This is also maximal ideal of Z10. Okay? Because for the ideal 2 there exists no proper ideal other than 2. Similarly, for ideal 5 there exists no proper ideal other than 5. So 2 and 5, this is only proper ideal, to only maximal ideal. Similarly, in Z10, number of maximal ideal in Z10 are omega n, which is actually number of prime divisor of n. Prime divisor of n, and this is equal to 2 times 5 equal to 2. Actually, the number of maximal and prime ideal in Zn is same formula, number of prime divisor of n, which is actually denoted as omega n. Question: let n denote the number of maximal ideal of Z p square q, where p and q are prime number, then value of n. Here Z p square q, if p equal to q, then p square q equal to pq, then number of prime divisor of n n is the number of prime divisor. Number of prime divisor, this would be 1, and when p not equal to q, then this value would be 2. Means when p not equal to q, then the maximal ideal is ideal generated by p and ideal generated by q. That means for p equal to q, number of prime divisor is only 1, and when p not equal to q, then number of prime divisor is 2. That means 2 and 3 is the right option. I hope my all viewers have understood clearly how we have to find number of maximal ideal by prime divisor, number of prime divisor. Okay. Today I will stop here. In my next video I will discuss some properties of maximal ideal and prime ideal. Okay. See you soon. Stay safe and stay positive always, and don't forget to subscribe my channel for more videos. Thank you so much.